Jai Shri Gurudev. Good morning to everyone, student. The next concept is properties of alcohol. You know well there are two types of properties, the physical properties and chemical properties. Let's take the first one, physical property. In this physical properties, the alcohols having high boiling point compared to the respective hydrocarbons. That is, the first one is alcohols has a higher boiling point than respective hydrocarbons. For example, see the methanol CH3OH. This methanol is high boiling point. It has a high boiling point than methane CH4. See, this methanol is derived from methane. Methane indane methanol bandirodu. One hydrogen ತೆಗೆದುಬಿಟ್ಟು OH ಹಾಕಿದಾಗ methanol ಬರುತ್ತೆ. ಆದರೆ this methanol ಅನ್ನೋದು ತುಂಬಾ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇರುತ್ತೆ ಕಂಪೇರ್ ಟು ದಿಸ್ methane due to the formation of weak hydrogen bond. For example, see, take methane CH3 bond OH. Example, take methanol. Here there is a hydrogen bond hydrogen, right? If you take one more molecule of methanol like that, see here actually the bond of methane and hydrogen is like that, like bind shape. Now this hydrogen form a bond with another hydrogen of this methanol 4CH3 like that. ಈ ತರ hydrogen oxygen ಮಧ್ಯೆ ಒಂದು weak hydrogen bond form. This is called hydrogen bond. Due to the presence of this kind of bond in alcohols having high boiling point than respective hydrocarbons. Okay, I hope you understanding. This is the first physical property. Then second one, the length of the carbon chain increases, the boiling point of an alcohol decreases due to avoiding the formation of hydrogen. That is the length of or molecular mass, either say length or molecular mass. Molar mass of compound or molar mass of an alcohol increases, boiling point increases. Molar mass increase ಆಗ್ತಿದ್ರೆ boiling point increase ಆಗ್ತಿರುತ್ತೆ. For example, see the methanol or CH3 CH2 bond OH or CH2 bond CH2 bond OH. This propanol 1, 2, 3, the carbon chain increases, right? The molecular mass also increases, so that the propanol has high boiling point when ethanol CH3 bond CH2 bond OH, then methanol CH3OH. Okay, like that means the length of carbon chain or the molecular mass of a compound increases, the boiling point increases. Then third one, this is molar mass or length of carbon chain. C chain means carbon chain. And branching increases, means branching of alcohol increases, boiling point decreases due to decrease in the molecular surface area. ಏನಾಗುತ್ತೆ ಬ್ರಾಂಚಿಂಗ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಿದೆ ಅಂದರೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅನ್ನೋದು ಡಿಕ್ರೀಸ್ ಆಗ್ತಿರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸಿ butanol, take butanol, N-butanol, CH3 bond CH2 bond 1, 2, 3, 4 CH2 bond OH. This is what N-butanol, right? This one has a high boiling point than the secondary butanol. See, CH3 bond CH, CH2 bond OH bond CH3. This is N-butanol. 1, 2, 3, 4. 4 carbon atoms, butanol, linear, so normal butanol. See here 1, 2, 3, 4. 4 carbon atoms. These two having same molecular formula, but the structures differs. These are called isomers, structural isomers. Now, then this one. See, again I write one more CH3 bond C, CH3 bond CH3 bond OH. This is tertiary butanol. This is a secondary butanol. This is a tertiary butanol. Tertiary butanol. So among these three, N-butanol has high boiling point, then secondary, then tertiary butanol. Because here the length is higher, hence it occupies large space, means large molecular space. Now the length of the carbon chain bit decreases compared to this one, so it occupies very less space, molecular space, and this increases branch. See, branch ಜಾಸ್ತಿ ಆಗಿರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, ಇದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಇನ್ನೂ ಕಡಿಮೆ ಸ್ಪೇಸ್ ಆಕ್ಯುಪೈ ಆಗಿದೆಲ್ಲ ಕೋಡ್ ಮೇಲೆ ನೋಡಿ. So that like that the molecular surface area is decreases by increasing the branch of a compounds or a alcohol, hence boiling point decreases. Okay, these are some physical properties. Then the next one is see, if a boiling point increases, the surface area is decreases. Similarly, the next one is solubility of alcohols is increases in water due to the formation of hydrogen bond. Already ತೋರಿಸಿದೆ ಇಲ್ಲಿ ಯಾವ ತರ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅಂತ. ಅದೇ ರೀತಿ ಮೆಥನಾಲ್, ಎಕ್ಸಾಂಪಲ್ ಟೇಕ್ ಮೆಥನಾಲ್ ಬಾಂಡ್ O bond H. If it is dissolved in water, the water is H bond O bond H, right? This is water. Here the bond is formed between oxygen and hydrogen of a water molecule, so that the solubility is increases the alcohols in water. It means the alcohol solubility is higher in water. Okay, then the branch of an alcohol increases, the solubility is decreases due to the non-formation of hydrogen bond. ಅಂದ್ರೆ ಲೆಂತ್ ಅನ್ನೋದು ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಕಾರ್ಬನ್ ಚೈನ್ ಅನ್ನೋದು ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗೋದು ಕಡಿಮೆ ಆಗ್ತಾ ಇರುತ್ತೆ. Therefore the solubility is decreases. Similarly, the branch of an alcohol is increases, the solubility increases due to the formation of strong hydrogen bonding. Hence the solubility of an alcohol is higher in water, and the branching alcohols is high soluble, and the length of a carbon chain increases, the solubility decreases. This is the physical property of an alcohol. Now take chemical properties. So the next property of an alcohol is chemical property. In this chemical property, the chemical properties having two types based on the cleavage of bond. You know, in alcohols there are two types of bond. For example, see RCH2 bond OH. This R is general group. Here we can see two types of bonds. That is C, carbon oxygen bond. This is carbon oxygen bond, and oxygen hydrogen bond, not for oxygen hydrogen bond. This is a alcohol, right? This is one type of bond, this is second type of bond, this is first type of bond. Okay, this is first, second type. There are two types of bond in alcohol, that is OH bond and carbon hydrogen bond. Based on the cleavage of these two bonds, we are classified into two types of chemical properties. Now the first one is cleavage of OH bond. Chemical reactions involved in cleavage of OH bond. This cleavage of OH bond indicates the acidic character of an alcohol. Now first one, acidity of alcohol. This OH cleavage character indicates the acidity of alcohol. Example, alcohols is treated with the metals like sodium or potassium or aluminium. It releases hydrogen gas and forming respective alkoxides. respect to alkoxide. This chemical reaction indicates the acidic strength of an alcohol. See here, they take general alcohol CH2OH. This is general alcohol, right? Now we are going to study the cleavage of OH bond reactions. This alcohol is treated with sodium metal. Sodium metal, it gives, see, take two equivalents. Now this bond is cleared. It means the bonded electrons moves towards the oxygen side, and hydrogen of one molecule and another molecule means same molecule of another same molecule of another hydrogen get combined together and form hydrogen gas. See, or CH2 bond O minus, two equivalents and Na plus. Here take two equivalents plus hydrogen of one molecule and hydrogen of another molecule becomes H2 gas. So this is called sodium alkoxide. Sodium alkoxide. Okay. Now it releases hydrogen gas that indicates the acidic character of an alcohol. Similarly, observe the example, take a methanol CH3 bond OH which is treated with sodium metal, two equivalents. This hydrogen of one molecule and another molecule of hydrogen becomes hydrogen gas, and the sodium with methanol, that is CH3 bond ON minus plus, two equivalents. So this is called sodium methoxide. Sodium alkoxide means methoxide. Okay. So similar, if you take a secondary alcohol, this is primary alcohol. If you take secondary alcohol means CH3 bond CH bond CH3 OH. This is secondary alcohol, right? Similarly, I take two equivalents. The secondary alcohol is again treated with either sodium, potassium or aluminum, any metal. Take aluminum, your wish, anyone. If you are taking aluminum, take 6 equivalents here to balance the chemical reaction. Take 6 equivalents. Now 1 equivalent of aluminum reacts with 6 equivalent. See, it gives CH3 bond CH bond CH3. Here O and aluminum bond is cleaved, right? Bond O. Take two equivalents of aluminum Al. This is tries, and here two aluminum and this molecule. Okay, so like that you get plus 3 equivalents of hydrogen gas. Here you get aluminum 1, 2, 3. What 2 propoxide, aluminum 2 propoxide. You get to aluminum 2 propoxide. Similarly, if you take tertiary butanol, means tertiary alcohol, you get respective sodium tertiary butoxide. Now, from this chemical reaction, you can decide the acidic character. It means primary alcohols has high acidic character, then secondary and the tertiary. Okay, the acidity character is primary alcohol is higher than secondary alcohol and tertiary alcohol due to the presence of electron donating alkyl group. See, this is the primary alkyl group, methyl. This methyl group is electron donating group. It shows positive inductive effect. Methyl group ಅನ್ನೋದು electron donating group ಆಗಿರುತ್ತೆ. Positive inductive effect ತೋರಿಸುತ್ತೆ. ಏನಂದ್ರೆ electrons ಈ ಕಡೆ ಡೊನೇಟ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ ಆಕ್ಸಿಜನ್ ಕಡೆ ಡೊನೇಟ್ ಮಾಡ್ತಾ ಇದ್ದಾಗ ಆಕ್ಸಿಜನ್ ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಇವೆರಡರ ಮಧ್ಯೆ ಒಂದು ಬಾಂಡ್ ಇದೆ Cl. ಇಲ್ಲಿ ನೋಡಿ CH3 ಬಾಂಡ್ O ಬಾಂಡ್ ಹೈಡ್ರೋಜನ್ ಈ ತರ ಇದೆ ಅಲ್ವಾ. ಸೊ methyl is electron donating group. ಡೊನೇಟಿಂಗ್ ಅಂದ್ರೆ ಏನು ಮಾಡ್ತಾ ಇದೆ, ಡೊನೇಟ್ ಮಾಡ್ತಾ ಇದೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಯಾವುದಕ್ಕೆ? ಆಕ್ಸಿಜನ್ಗೆ. ಆಲ್ರೆಡಿ ಆಕ್ಸಿಜನ್ ಮೇಲೆ 2 pairs ಲೋನ್ ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಚ್ ಇದೆ. And the hydrogen is electron deficient or positive, electro positive atom ಆಗಿರುತ್ತೆ. ಡೆಫಿಷಿಯಂಟ್ ಅನ್ನೋದಕ್ಕಿಂತ ಪಾಸಿಟಿವ್ ಆಟಮ್ ಆಗಿರೋದ್ರಿಂದ ಈ ಬಾಂಡೆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಕ್ಸಿಜನ್ ಕಡೆ ಮೂವ್ ಆಗಬೇಕು, ಹೈಡ್ರೋಜನ್ H+ ಆಗಬೇಕು. ಓಕೆ, ಆದ್ರೆ ಇಲ್ಲೇನಾಗುತ್ತೆ ಅಂದ್ರೆ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಅನ್ನೋದು ಡೊನೇಟ್ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದು ತಗೊಳ್ಳೋದಿಲ್ಲ, ಇನ್ನೂ ಜಾಸ್ತಿ ಆಗೋದ್ರಿಂದ ಏನ್ ಮಾಡುತ್ತಂದ್ರೆ ಈ ಆಕ್ಸಿಜನ್ ಹೈಡ್ರೋಜನ್ ಜೊತೆ ಜಾಸ್ತಿ ಕ್ಲೋಸ್ ಆಗಿ ಬಾಂಡ್ ಆಗುತ್ತೆ. Okay, that is called positive inductive effect. Due to that nature, it less releases H plus ion. Kadame release ಮಾಡುತ್ತೆ H plus ions. Compared to the secondary and tertiary alcohol, it releases more. ಸೆಕೆಂಡರಿ ಮತ್ತು ಟರ್ಷರಿಗೆ ಕಂಪೇರ್ ಮಾಡಿಕೊಂಡ್ರೆ ಇದು ಜಾಸ್ತಿ H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಅನ್ನ ರಿಲೀಸ್ ಮಾಡುತ್ತೆ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್. ಯಾಕೆಂದ್ರೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಟೇಕ್ ಸೆಕೆಂಡರಿ ಮೀನ್ಸ್ O ಬಾಂಡ್ H ಬಾಂಡ್ C ಇಟ್ ಕಂಟೈನಿಂಗ್ 2 methyl group. ಈ ತರ 2 methyl groups ಇರುತ್ತೆ, ಒಂದೇ ಒಂದು ಹೈಡ್ರೋಜನ್ ಇರುತ್ತೆ ಅಲ್ವಾ ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್ಗೆ. ಸೊ ಹಿಯರ್ ದೇರ್ ಇಸ್ 2 electron donating groups. ಎರಡು ಡೊನೇಟಿಂಗ್ ಗ್ರೂಪ್ಸ್ ಇದೆ, ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಡೊನೇಟ್ ಮಾಡ್ತಿದೆ ಅಂದ್ರೆ ಮತ್ತೆ ಕಾರ್ಬನ್ ಆಕ್ಸಿಜನ್ ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಡೊನೇಟ್ ಮಾಡುತ್ತೆ. ಇಲ್ಲಿ ಒಂದು ಗ್ರೂಪ್ ಡೊನೇಟ್ ಮಾಡ್ತಿದೆ, ಇಲ್ಲಿ ಎರಡು ಗ್ರೂಪ್ ಡೊನೇಟ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಆಫ್ ಆಕ್ಸಿಜನ್ is much more increases, hence it very closest to the hydrogen, or it makes a strong bond between oxygen and hydrogen, so that the H plus ion do not release as easily then compared to the primary. However, the tertiary never to be released. ಆದರೆ tertiary alcohol ಅನ್ನೋದು ರಿಲೀಸ್ ಮಾಡೋದಿಲ್ಲ. Okay, therefore the primary alcohol is more acidic, secondary and tertiary. This is the acidic character that determined by the alcohols reacts with metal. See, there is a reasoning question on the basis of acidic character, that is alcohols are less acidic than water. Due reason. See, alcohols are less acidic than water. Due reason. Very important for 2 marks. Why alcohols are less acidic? Already I told, due to the presence of electron donating group or methyl group, the primary alcohol is more acidic than secondary and tertiary. So here the totally alcohols, either it may be primary, secondary and tertiary, doesn't matter, those are less acidic than water. It means water are more acidic than alcohol. See, the alcohol CH3 bond OH, this is alcohol. In this alcohol, after ionizing, means after cleavaging of this OH bond, you get the CH3 bond O minus plus H plus. Okay, here there is a alkoxide ion. Alkoxide ion and H plus ion. Now, if you take water, H bond O bond H, this water. Here, after cleaning this OH bond, it gives OH minus plus H plus ion. This is called hydroxide ion. Hydroxide ion. This is the reason. See, when ionizing this methanol, you get a methoxy ion or alkoxide ion. After ionizing water, you get a hydroxide ion. Among these two, here there is a methyl group, that is electron donating group. It shows a positive inductive effect. Electron donating group shows positive inductive effect. Hence, this alkoxide ion is high stable. High stable means attached stability. That leads to the decrease in the acidic character of alcohol. But in this hydroxide ion, there is a hydrogen group. This hydrogen is electron withdrawing group, not donating group and not withdrawing group. Donating group withdrawing individual hydrogen, no? Just is an element. However, it full electrons towards itself. Positive nature ಇರೋದ್ರಿಂದ ಇದರ ಕಡೆ ಫಿಲ್ ಮಾಡ್ಕೊಳ್ಳೋದ್ರಿಂದ ನಾವು withdrawing group ಅಂತ ಹೇಳ್ಬೋದು. Okay, you can say it is an withdrawing group. Hence, it decreases the stability of hydroxide ion, so that the water is more acidic than alcohol. Water is more acidic, it means alcohols are less acidic than water. Okay, this is the reason, important for 2 marks. Then second chemical property is esterification. The second one chemical property is esterification. Important. So esterification is the process of forming ester when reacts with carboxylic acid and alcohols in presence of concentrated sulfuric acid or dry HCl. That is when carboxylic acid, that is R bond C double bond OH, This carboxylic acids, you know the carboxylic acid gender structure. This is the carboxylic acid which is react with alcohol. You know alcohol, R bond OH. This is alcohol, right? These two are react together in presence of concentrated sulfuric acid H2SO4 or dry HCl. Removal of hydrogen takes place, and this is the reversible reaction. This is the reversible reaction, so that it should necessary to remove water as soon as possible. Okay, so observe here H bond O. You know, we are studying the cleavage of oxygen and hydrogen bond, right? So oxygen hydrogen bond is cleaved with the OH bond, we get H2O. H2O is the water. Due to the reversible reaction nature, it removes water, and we have to be remove water as soon as the chemical reaction is done. See, the remaining thing is R bond C double bond O bond O bond R. So here this is the functional group of ester. Okay, so its name is called as ester. This whole process we called as esterification. Okay, the process of formation of ester we called esterification. The ester is formed by treating carboxylic acid with alcohol in presence of concentrated sulfuric acid or dry HCl. It is a reversible reaction, so that the water can be removed as soon as the chemical reaction is completed. This is the esterification. So example C, take formic acid or acetic acid. CH3, C double bond O, bond O bond H. This is called acetic acid. Acetic acid plus take methanol, H bond O bond CH3. This is methanol. So complete the reaction. What you get by putting concentrated sulfuric acid. This is the reversible reaction. Concentrated sulfuric acid or dry HCl. What you get, this hydrogen and this oxygen and hydrogen becomes water, and the remaining thing is CH3 bond C double bond O bond CH3. Okay, CH3 C double bond O CH3 plus H2. So what its name? That is methyl acetate. Methyl acetate. Its name is methyl acetate. Methyl acetate is the name. Similarly, take one more example. This is example 1, 2. In example 2, take acetic acid. CH3 bond C double bond O bond hydrogen plus in place of methanol take ethanol, that is bond O CH2 bond CH3. So this is ethanol. So which is reacts in presence of concentrated sulfuric acid. So what type of product we expected? Here also HOH. These two becomes water. The remaining is CH3 C double bond O CH2 CH2 CH3. That is CH3 C double bond O bond CH2 O bond CH2 CH3. What its name? Ethyl acetate. Okay, this is methyl acetate. Now ethyl acetate. Ethyl acetate plus water. So this is called as esterification. There is so many kind of esterification products. Either you can treat it with benzoic acid with methanol or benzoic acid with ethanol. You get methyl benzoate and ethyl benzoate respectively. Like that. This is one of the kind of esterification. Okay. Now this esterification reaction shows fruity odor. Fruity odor ಮೀನ್ಸ್ ಫ್ರೂಟಿ ಸ್ಮೆಲ್ ಕೊಡುತ್ತೆ ಒಂಥರ, ಇಟ್ ಈಸ್ ಎ ಗುಡ್ ಫ್ಲೇವರ್, ಒಂದು ಒಳ್ಳೆ ಸ್ಮೆಲ್ ಬರುತ್ತೆ. ನೀವು ನೋಡಿರ್ತೀರಾ, ನೆಕ್ಸ್ಟ್ ಲ್ಯಾಬಲ್ಲಿ ನೋಡ್ತೀರಾ ಎಸ್ಟರಿಫಿಕೇಶನ್ ಟೆಸ್ಟ್ ಮಾಡಿದಾಗ ಇಟ್ ಗಿವ್ಸ್ ಫ್ರೂಟಿ ಓಡರ್. ದಿಸ್ ಫ್ರೂಟಿ ಓಡರ್ ಸ್ಮೆಲ್ ಇಂಡಿಕೇಟ್ಸ್ ದಿ presence of carboxylic acid, or it is the one of the tasks to show and to confirm the carboxylic acid group. ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಗ್ರೂಪ್ ಇದೆಯಾ ಇಲ್ವಾ ಅಂತ ಕನ್ಫರ್ಮ್ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಇದೊಂದು ಟೆಸ್ಟ್ ಆಗಿರುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ದೆನ್ ದಿ ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಟಿವಿಟಿ ಆಫ್ alcohols towards the esterification is primary alcohol is more reactive than secondary alcohol and tertiary alcohol. This is the order of reactivity of alcohol towards the esterification, and similarly the order of reactivity of carboxylic acid towards the esterification is also a same order. ಅಂದ್ರೆ ಆಲ್ಕೋಸ್ದು ಮತ್ತೆ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಎರಡು ಸೇಮ್ ಆರ್ಡರ್ ಆಗಿರುತ್ತೆ. ಪ್ರೈಮರಿ ಆಲ್ಕೋಸಿಸ್ ಅಂಡ್ ಪ್ರೈಮರಿ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಇಸ್ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್ ದೆನ್ ಸೆಕೆಂಡರಿ ಅಂಡ್ ಟರ್ಷಿಯರಿ. Okay, this is the esterification reaction and means second chemical property. Third chemical property is acetylation. Acetylation. So in this process, alcohols are treated with acid chlorides in presence of base pyridine. It forms ester and release of HCl. This HCl neutralizes the pyridinium to form pyridinium hydrogen chloride salt. Okay, it can be easily removed. For example, see the chemical reaction. Alcohol is hard bond OH. This alcohol, right, is treated with acid chloride. The acid chlorides are Cl bond C double bond O. Sorry, the acid chlorides are hard bond C double bond O bond Cl. This is acid chloride. Acid chloride. You can also write hard C double bond O Cl like reverse. I am write for our convenience. See here, it is reacting presence of pyridinium. These two get combined together. H and Cl becomes HCl, and remaining one is hard bond O bond C double bond O bond hard. This is what? Ester. Plus get HCl is byproduct HCl. This HCl is react with pyridine and form pyridinium salt. See here, the pyridine structure is this one. This is pyridine. This pyridine is react with HCl. It form H plus and Cl minus, right? Nitrogen having no free electrons get abstract, get pyridinium salt. This one. N bond H, nitrogen carries positive charge and Cl. This is pyridinium salt. This salt can be easily removed from ester. You get pure ester. Okay, this is the simple process to prepare ester from acid chlorides and alcohols. Now, for example, take any alcohol. Take methanol, CH3O bond H, methanol. This methanol is treated with acetyl chloride, that is Cl bond C double bond O bond CH3. Acetyl chloride, which is presence of base pyridine. You can write PY, simply pyridine. Now this Cl and H becomes HCl, and remaining is CH3 bond O bond C double bond O bond CH plus HCl. So its name is, already I told you, methyl acetate. Okay, this is the one of the way to use it to cleave OH bond. Okay, remember we are studying the reactions that involve the cleavage of OH bond. Now one more example, see the alcohols that we get with the acetic anhydride. Acetic anhydride is also one of the carboxylic acid derivative. Observe CH3, C bond O bond H. We are taking methanol. This methanol is treated with the acetic anhydride. The acetic anhydride is CH3, C double bond O bond C double bond O CH3. So this is the acetic anhydride. These are the compounds of anhydrides. Okay, this anhydride. This anhydride also reacts with alcohol in presence of base pyridine. Here see you get this hydrogen OH bond is cleaved and along with this whole group. It forms a compound, one compound that is a CH3 C double bond O bond H and CH3O C double bond O CH, this one compound. Now write first one CH3, this one, then O, then write this one C double bond O bond CH3. So these two are same, right? Methyl acetate plus the remaining is CH3 C double bond O and H. CH3 C double bond O, this one O and H. What its name? This is acetic acid, right? Acetic acid. You get acetic acid here, methyl acetate. So this is also one of the reaction used to cleave OH bond. Okay, these are some reactions. The fourth method will be studied in next class.